Hi! Wow! Number properties. Year 8 textbook. Extra chapter 1. Wow, what are we talking about this number properties? Well, ladies and gentlemen, welcome. We're following the Cambridge Essentials scheme as I record these videos for my students and anyone who is watching in internet land. Number properties. When you know this type of stuff like multiplication and division, and the last lesson we looked at, what did we look at? We looked at mental strategies to help us. All of these things build to make a big picture to help us actually do more complicated questions. Ooh, did I say complicated questions? Not in this exercise, I should go. So, those who are working with me, those are the questions in the Year 8 textbook. Chapter 1, Exercise 1C. There are some extension questions here that are funky as funky. Recap. Do you like my little joke there? Yes, I know, it's a cap. To be able to remember something, apparently, if you do something 20 times, it will pass from short-term memory into long-term memory. Well, that's pretty awesome. That's why sports people do so much practice. And the same must be true for mathematics. The reason we get you to do lots of questions is so that you can practice and pass it from your short-term memory into your long-term memory. So, realistically speaking, the rest of the work we're going to do is actually consolidation. It's work we've already done that will allow you to remember and just put it from that short-term memory into the long-term memory. So let's just go and do a swift lesson today. Language. Multiple. Remember, multiple, in my view, sounds like multiply. It means you're looking for all of the answers which are in the times table of the number you're looking for. You're going to, huh? So for example, find the first multiples of 8. That is basically saying find the first 5 numbers of the 8 times tables. Now, if you don't know your 8 times tables, well, you need to learn them. And you're going to turn around and say, but I can't learn them, I've tried. You tried in year 5. Your brain is now 4 years older. Give it a go. You can do this. I believe in you. I believe. So, basically, the 8 times table, as I've said here, is 8, 16, 24, 32, and 40. Those are the first 5 multiples of 8. Wow! Lowest common multiple, right? And again, this is the question where they actually give you the answer in the title. You are looking for the lowest, i.e. the lowest, I can't put lowest any other way, common, the ones they share, multiple. So the lowest common multiple, which number do they share for both of their times tables? All right, so here's an example. So I want the lowest common multiple of, let's say, 3 and 8. Well, the first thing I'm going to do is I'm actually going to write out my 3 times table. 3, 6, 9, 12, 15, 18, 21, 24, and I'm not sure I need to go any further. Why? Because I sort of know my 8 times table. So if I do my 8 times table, it's 8, 16, 24, 32, 40. What do you notice? What is the first and lowest number they share? Well, they don't have 8 in common. They certainly don't have 16 in common. Oh, hello. There is 24. So because that is the lowest number in their times tables, we can say that the lowest common multiple of 3 and 8 is equal to 24. Now, there are other ways of doing this. I could have done a factor tree, and if you remember, the factor tree actually helps you find this out, as long as you remember an algorithm. But yes, we come back to that algorithm business. Wow, can't escape rules in maths, can we? That's one way of finding the lowest common multiple. Now, when you get to factor, this is a number which can divide into another number without leaving a remainder. All right, so we know, because we talk about prime numbers and composite numbers, oh, hello, coming to those in a moment, that prime numbers only have 2 factors, one in itself. Composite numbers have 3 factors, or 3 or more factors. But if we're looking for factors of 36, we are looking for all the numbers that will divide into 36 a whole number of times. Now, again, there's lots of ways of doing this. You can do 1 and 2 and 3 and 4 and 6, 7, 8, 9, 8, 7, 36, and 9, and 18, and 36. Now, if you're really good at your times tables, you can just put these down straight away. Another way of remembering these is called factor pairs, because we know that the first and the last factor will always multiply to give 36. And actually, every pair, as we work towards the middle, will always multiply to make 36 in this particular instant. So if I'm looking for the factors of 36, I could actually do it to say, well, 1 and 36. So 1 times 36. 2, yes, and 2 times 18 gives me 36. 3, yes, and 3 times 12 gives me 36. Does 4 go in? Yep. 4 goes in 9 times. And then we get this 1 left on its own, this 6. Now, the reason I chose 36 is because it's also a special number. Most times we will have an even number of factors. When we end up with an odd number of factors, like we've done here, i.e. there's a number sat on its own, because you can't write 6 and 6, it doesn't make any sense, then we also know that 36 is actually what we call a square number. Now we're probably rushing a bit here, but using this idea here now, this factor pairs, if I needed to, I'd write them out as 1, 2, 3, 4, 6, 9, 12, 18, and 36. I've done the hard work by writing it in the table, and I can just write it down. Now you might turn around and say, well, hold on a moment, why didn't you write all of the factors? Why did you only write 4? Well, because the question said, find the first 4 factors. Always a good idea to read the question, always. So, knowing what a factor is, how do we then find the highest common factor? Well, again, it can be done in so many different ways. Number 1, you can do it the long way. So, if we wanted to try and find the highest common factor of 24 and, I don't know, 50, for example. Highest, we're looking for the biggest number that we'll share. So, first things first, let's look at the factors of 24. So 1 and 24, 2 and 12, just 3 go into 24, 21, 24, yep, 8 times, 8, 16, 24. Does 4 go in there? Yep, 6 times. 5 go in there? Nope. And there we go. So there are all my factors. And what do you notice? They're an even number. So there's 8. So there's an even number of factors, so that is not a square number. So 24 has 1, 2, 3, 4, 6, 8, 12, and 24. What about 50? Right, 50. Same thing. 1 and 50, 2 and 25, 3 no, 4 no, 5, yep, 5 and 10, 6, nope, 7 no, 8 no, 9. Well, that's it again. So 50, nice and easy one. 1, 2, 5, 10, 25, and 50. So we're looking for the highest number that they share. 50 no, 25 no, 10 no, 5 no. Wow. The highest number they share is actually 2. So the highest common factor of 24 and 50 is actually equal to 2. Ooh, there we go. Now again, you can do this using prime factor decomposition and factor trees, right? That's in a video in year 7. By all means, knock yourself out and go and watch it. Otherwise, this is another way of doing. So, prime number. Now that we know what a factor is, we've said here, this is a number which can only be divided by 1 and itself. And these are really, really important pieces of information. 1 is not prime. So before you go any further, if ever they ask you to list the first 5 prime numbers, please don't put 1. 2, 3, 5, 7, and 11. Good. Please don't say 9, because as I say here, 9 is not prime either. Why? Because it can be divided by 3. So, what do we notice about the number 2? Well, it's actually a prime number, and it's the only even prime number. So then again, these are really, really important. It's always a good idea to memorize the first 10 prime numbers. If you have like a summary book or a workbook or a notebook, write the first 10 in. And if you're allowed to take it into an exam, you've just gained an easy mark, because all you're going to do is open up your summary book and just write them in. Okay? Alternatively, memorize them. Do it 20 times, as we say. Put something in your brain 20 times and it's there forever. Composite numbers. These are numbers which have more than 2 factors. Now, someone recently put in a test. A composite number is every number that isn't prime. Sadly, wrong. Why is it wrong? Because 1 is not a composite number. So if you were to list all of the numbers that aren't prime, so let's say 2, 3, 5, 7, 11, let's just imagine. So if we now list all the numbers that aren't in that list, 1, 4, 6, 8, 9, and 10, well, sadly, 1 isn't composite. All the rest of the numbers are. So your first composite number is actually 4, because that has the factors of 1, 2, and 4. But by writing down a statement that a composite number is every number that isn't prime, sadly is not right. So again, remember, 1 is not composite. We talked a moment ago about square numbers. If you remember, square numbers are numbers that are basically found when you multiply something by itself. So 1 squared, which is how we write square numbers, is the same as 1 times 1, which is 1. And 2 squared is the same as 2 times 2, which is equal to 4. And 3 squared is 3 times 3, which is equal to 9. And as the question says, 4 squared must be equal to 4 times 4, which is 16. Now again, my advice to you is if you have a notebook or a summary book, write down the first 10 or so square numbers. 1, 4, 9, 16, 25, 36, 49, 7, 8, 64, 81, 100, 121, and 144. So those are the first 12 square numbers, because 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, and so it goes on. Other numbers you should really try and remember is 169, 196. So that's actually 13 times 13 and 14 times 14, and then 225, which is 15 times 15. If you can remember those as well, or put those in your summary book, you'll find that they come up a lot in exams as well. So, knowing what a square number is, what is a square root? Well, as I say there, to find the square root of a number, you're asking yourself the following question. What number, when multiplied by itself, hold on a moment, that sounds like a square number. Oh my goodness gracious me, yes! Because a square root is the opposite of a square number. So if we know what number multiplies by itself, we can find its square root. And as we can see here, our square root is written like that. It has its own little symbol. That's funky. So if we are looking for the square root of 81, we are basically saying in our head, what number when multiplied by itself gives me 81? Well, there is only one number that when multiplied by itself gives me 81. It's 9, because 9 times 9 is equal to 81. So that is my working out. What about the square root of 100, for example? Well, 10, because 10 times 10 is 100. What about the square root of 169? Oh, remember I gave you this one? Yep, it's equal to 13. Now, generally speaking, we should put a little 2 here, because that little 2 tells us to find two numbers that when multiplied by itself give us 169, because that leads beautifully into cube numbers. Now, the reason we don't write that little 2 is because we're lazy. And actually, we can generally, like we don't write 1 times, because the number 1 is just obvious. That little 2, we don't write it because we just know that a square root means square root, find the opposite of the square. But cube roots, we have to use a little floaty 3. But what is a cube number? Well, a cube number, if a square number was written as 1 squared, then a cube number is written as 1 cubed, little floaty 3. And that means 1 times 1 times 1, which is actually 1. And 2 cubed would be the same as 2 times 2 times 2, which is 8. And as the question says, 3 cubed is 3 times 3 times 3. Now again, 3 times 3 is 9, times by 3 is 27. So there we go, it is 27. And 4 times 4 times 4 is way too big for my little brain to try and work out. 64, I've done it. So cube numbers are where you take the number and multiply itself 3 times. And so if I had, and moving on, if I had 2 to the power of 4, hopefully everyone would realize that would be 2 times 2 times 2 times 2. All right, so 2 times 2 times 2 times 2 is 2 times 2 is 4, 8, 16. Using the idea that we had then with square roots, and as I just said there, a cube root, the way we know that we're finding cube root is we put a little floaty 3 there. So if I had the cube root of 64, what that is saying is, what number multiplied by itself 3 times would give me 64? And because I just gave you the hint a moment ago, the answer would be 4. Now, this number here is really quite much smaller than that one. And you have to realize that if you were trying to work out the cube root of 8, for example, It's got to be a really small number. Now, I always start with 1, then 2, then 3. And again, in your formula book or in your summary book or your notebook, you're always a good idea to write down the first 5 or 6 cube numbers because it'll help you find out cube roots much quicker. 8, I just happen to know, is the same as 2 times 2 times 2. Believe it or not, ladies and gentlemen, that's it for number properties, right? Those are the questions I would very much like you to do if you're following along. Otherwise, I hope you've learned something useful. Brilliant having you. I look forward to seeing you next time. Thank you very much for joining us for that video. It was really good having you. Now, if you'd like to know when the next video is coming, why not click on subscribe? Alternatively, head on over to MaffsGuru.com where you can watch all of the videos on its own dedicated website. While otherwise, watch the video that's just popped up. It'll be part of this series. All right, take care. See you again soon.